Hi there and welcome. My name is Rebecca Weaver. I'm going to be looking at Chapter 7 of Applied Calculus today. This chapter is about functions of several variables, so it's about to get exciting. In section 7.1, we're going to be looking at examples of functions of several variables. Now, for our functions of more than one variable, we need to define functions of several variables. This is a function that has more than one independent variable, such as the function f of x, y, z, and w. And this might equal something like xy squared all over 5z minus w. It's just a function with all of those different variables in it. So let's look at an example such as f of g, x, and y, and that equals the square root of x squared plus 2y squared. And we're going to compute g of 1, 1 and g of 0, negative 1. Now that means that x is going to be 1 and y is going to be 1 in the first case. And in the second case, we'll get x is 0, y is negative 1, and we're just supposed to plug those in. So here we are plugging those values in for x and y for x equal 1, y equal 1, and we would get that that g of xy equals the square root of 3. And when we plug in g of x negative 1, just plugging that into the function, the square root of x squared plus 2y squared, we get the square root of 2. So just kind of plug and chug out your answer. An example in cost of material would be, let's find the formula for cost, and this cost relates to and is a function of both x, y, and z, and that gives the cost of material for the rectangular enclosure in the figure with dimensions in feet, and assuming that the material for the top costs $3 per square foot, material for the back and two sides is $5 per square foot. So we created a little table here so that we have the cost per square foot of the top is 3, and the area of that top going down is x times y. Then we have the cost of the left side is 5, and that area would be y times z. The cost of the right side is 5, and that area is yz. And the cost of the back is 5, and that area is xz. So finding that total cost, we just need the sum of the amount of cost for each side of the enclosure. So the cost of the square foot of back times the area of the back side in square feet is 5xz. Similarly, the cost of the top is 3xy, and continuing in this way, we see that the total cost is just going to be 3xy plus 5yz plus 5yz plus 5xz, and that's going to yield 3xy plus 10yz plus 5xz. And that's all to that one. So an example for tax and homeowner exemption. The value of residential property for tax purposes is usually lower than its actual market value. If V is the market value, then the assessed value for real estate taxes might only be 40% of that V. Now suppose the property tax, capital T, in a community is given by the function that T is a function of R, V, and X. And this function is R divided by 100 times the quantity 0.4V minus X, where V is the estimated market value of the property in dollars, and X is a homeowner's exemption, a number of dollars depending on the type of property, and R is the tax rate, stated in dollars per $100 of net assessed value. Now determine the real estate tax on a property valued at $200,000 with a homeowner's exemption of $5,000, assuming a tax rate of $2.50 per $100 of net assessed value. So now we're looking for T, and we know that V equals 200,000, X equals 5,000, and R equals 250. So just plugging those in to our function, we get that T is equal to 1875. So the real estate tax on property with those given characteristics is $1,875. So we need a definition now of level curves. For a function f of xy, a family of curves with the equations f of xy equals c, where c is any constant. Now we need an example of this. Find a function f of xy that has the curve y equals 2 over x squared as a level curve. And since the level curves occur where f of xy equals c, then we must rewrite y equals 2 over x squared in that particular form. So here's the given equation of this level curve. Y minus 2 over x squared equals 0. We just subtract it from both sides. Therefore, we can say that y minus 2 over x squared equals 0 is of the form f of xy equals c, where c is 0. So for f of xy, we have y minus 2 over x squared. And that's all we have for this particular section. Now, if you have any questions, you know what to do. Email me at rweaver10@alaska.edu and have a fabulous day.